Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 7D. Myself, Priyanshi Goyal, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Smart Trends in Computing and Communications, SMARTCOM 2025, Pune, India. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Pune, India, and the virtual event is being held through Zoom today and tomorrow, that is 30th and 31st of January 2025. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for the presentations and 2 minutes for question and answers. On 7 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all please stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Professor Ronak Kumar Patel. Welcome, sir. Professor Ronak Kumar Patel is an assistant professor in the Computer Engineering Department at CSPIT, Charusat. With over 7 years of research experience, his expertise spans machine learning, deep learning, and recommender systems. His area of interests are Python programming, parallel computing, high performance computing, operating system, documentation using LaTeX, LATX, sorry. He has served as a reviewer for international conferences and have published numerous research papers in esteemed international journals and conferences. I would now like to invite Professor Ronak Kumar to share a few words of encouragement with our attendees as we begin this session.
Okay, thank you very much, ma'am, for the introduction. And I'd like to congratulate all the participants that you people selected in this STS conference. And you got the opportunity to present your work and to connect with each other. So best of luck to everyone and stay connected with each other.
Thank you so much, sir. Now, to begin with, I would like to request Shiva Kumar Bandaru to kindly present his paper titled A Novel Mari Improvisation Based Parameter Aggregation Algorithm for Segmenting Brain Tumors in a Federated Learning Setup. Do we have you here with us, Shiva?
Yes, Priyanshi. 1 moment. I'll share my screen.
Yes, please. Just a second. Yes. Yes, your screen is visible.
Right. Let me start with that.
Can you just make it full screen? Yes. You
Yeah.
may start.
Yeah. Hello. Greetings to the panel members and fellow researchers. My research study is MRE improvisation-based parameter aggregation algorithm for segmenting brain tumors in federated learning setup. Myself, Shivkumar, and Upendra Pratap is my co-author, mentor. And our research study is an extension to parameter aggregation techniques in federated learning systems. So before we start, let's understand brain tumor segmentation problem, how it is solved in a conventional approach. So we have the brain MRI images, so and the associated tumor segments. So we train the model using this data, and once the model is trained, we feed the input and derive the predictions. That tumor segments. When you overlay these tumor segments, you have the shape, size, and location of the tumor. So this is a critical assignment. So to bring this in real time, now we face many challenges and issues such as data storage, challenges, patient privacy concerns, computational limitations, scalability issues, and risk of data loss. So to address these issues, we use federated learning in healthcare. So basically, federated learning is a paradigm which works on the approach of decentralized data and centralized model. So where we will have an global server or central server, and clients or local nodes connected to the central server. So initially, global model is sent to this servers, and the clients will receive the model, and then the client will train the model on the local data set and send back the updated models. So this is how the patient privacy is achieved. Rather than sending the data, you are only sending the updated models. So once the updated models from the clients received, the central server will use the parameter aggregation, federated averaging to derive the final model. So even this federated learning has its own challenges, such as communication overhead, system complexity. So the main issue we observed was in federated learning, all the clients were allowed for training for all the number of rounds, which is really inefficient. So when you consider, when a good client was a client model was able to generalize on its data. So when you are training, overtraining the models, so it would increase the communication cost, resource overutilization, higher computational expenses. So there will be a risk of overfitting the model. So this model, overfitted model on the network, acts as an imposter, which negatively impacts the training on other clients and potentially overfitting the final model. So for this, to address these issues, we proposed in our research MR improvisation for federated learning systems. So MR improvisation works on the approach of selective training and continuously evaluating each client after end of the round. So the concept remains the same as federated learning. Rather than allowing all the clients for all the rounds for training, we only allow a certain number of rounds for certain number of rounds. So we keep a threshold on the communication round. Once that threshold is reached, we start to compute the performance of each client. So we are looking at uh, brain tumor segmentation tasks. So we used Jaccard index and dice coefficient scores from the clients. We compute the average, and if they Jaccard index and dice values are greater than the average values, we consider the client as a strong client. Else, it is considered as weak client. So it hasn't able to generalize the data set. So we allow the weak lines for further round of trainings. So this is the approach. So using this method, we can save a lot of time. To give you an example, so let's consider same example here: 5 rounds for six rounds for 5 clients. So each client is taking 2 minutes. So to complete one round, uh, so 10 minutes is the overall time. So when we keep a round threshold on round three, so we evaluate J average and D average values and test each client's performance. So here in round 4, 1 to 4 are the weak clients. So we allowed training, and 3 and 5 are the strong clients. So here you can see only weak clients are allowed. So only 6 minutes of the training time. So eventually in the next rounds, the training time will be reduced. So this is how the this was the idea. So for this, to set up the experiment, we used 10 clients and 10 communication round. We kept round 5 as the threshold. So we used the Bratius 2028 dataset, which is a benchmark dataset, and we use the UNet model as it captures the spatial information on the brain MRI scans. So we used the 2015 samples of the brain tumor, 2000 samples on the dataset. So this is computationally expensive. So we used subset of data here. So even in this data set, we splitted the data into 90:10, and 90% of data set is further divided into 10 parts. So each client would get equal amount of data. So this was the idea. And coming to experiment results, we mainly focused on MRE improvisation output from the algorithm, and performance of clients, global model, and the final model predictions. So in MR improvisation output, we will first look at the participation of clients over the training rounds. So 5 clients were only participated for 5 rounds. So they were able to generalize the model on the local data sets. So these are strong clients, and next 3 clients were able to eventually improve, and 2 clients were weak. So when we also recorded the training time for each client. So 3.6 minutes was the training time for each client. So to complete the 1 round, it took around 36 minutes. So after the threshold, you can see only weak clients are allowed for training here. So it took 18 minutes. So eventually the time got reduced. So this is the visualization for it. Training time has been reduced. So first 5 rounds took 64% of the day to total training time, and 36% for next 5 rounds. So when you compare this with the vanilla FL setup, so our system is complete the training in 244.8 minutes itself. So the vanilla orthodox federated learning system takes 360 minutes. So we are saved around 15.2 minutes, which proves the theory as we are going at it. And so we are looking at performance of clients, and uh, so here is the decline of these are the loss score of clients, 10 clients for 10 rounds. So here you can see the decline. Next, the round 1 and round 10 comparison of dice coefficient scores for client, each client. So
This is a
here,
7 minutes reminder.
yeah, drastical improvement here. And this is the Jaccard index scores. And this is the global model performance. Uh, and this is the dice coefficient and the card index comparison of round 1 and round 2 of global model. So we have the final model predictions. So you can see the output here. So it was able to capture this all the tumor regions with the spatial information on the final model on the final round. So this is the final second sample of the prediction. That's it. Thank you.
Thank you, Shiva. Are there any questions?
Yeah. Hello.
Yes, sir. You're audible.
Yeah. Means how we have observed that the model is overfitting.
Yeah, we were the Jaccard and Dice index values have been when continuously training, the model was overfitting on the data itself. On the sample subset of data set we taken, the Jaccard index were expected more than what we are results were more than what we are expecting.
Is word that you are specifying in round 1 and in bracket 1, 2, 3, 4, 5. For those that 1, 2, 3.
I your voice is a bit low.
Okay. Am I audible now?
Hello.
Am I audible?
Yeah, no, it's better.
Okay. So in the round 1, round 2, round 3 that you have mentioned in bracket 1, 2, 3, 4, 5. What is that number in?
I couldn't understand your question. The voice is a bit low. Don't know what's the problem here.
It's the same for all.
Hello.
So your voice is breaking a little.
Okay. It's no
Can
problem.
you please? Yeah, it's better. Can you please repeat?
Okay. No issue. We can go further now.
Okay. Okay. Thank you, Shiva.
Thanks, Priyanshi. Thanks, Rohan.
Uh, right. Moving forward, just I would like to invite Shivani to kindly present her paper titled Analyzing Web 3.0 based Metaverse Banking Services through the lens of diffusion of innovation theory. Do we have you here with us,
Yeah, thank you,
Shivani?
Priyanshi. Yes, thank you.
Uh, your screen is half. Yes.
So, good
Yes,
evening,
yes.
everyone. I'm Shivani, and it is an absolute honor to present my research paper on Web 3.0 waste metaverse banking services through the lens of the diffusion of innovation theory. So, let's begin. So, this is the presentation outline. I'll be covering all of these 10 aspects. So, as all of us are aware of the fact that the financial industry is undergoing a significant transformation with the integration of blockchain, decentralized applications, and immersive virtual experiences. This study explores how metaverse banking is perceived, adopted, and the factors influencing its widespread implementation. So, Web 3.0 is the next evolution of the internet characterized by decentralization, blockchain technology, and user ownership of digital assets. The metaverse is a virtual, immersive environment where users can engage in social, financial, and business activities using avatars. Banks are now exploring virtual banking branches, blockchain based transactions, and digital asset management within this space. So, the DOI theory proposed by Rogers in 1995 explains how innovations diffuses among individuals and societies. So this study basically helps us to examine how metaverse banking fits into this framework, identifying key factors influencing adoption. Moving on to conceptual framework and literature review. The metaverse banking concept is relatively a novel concept with limited real world applications. However, technological advancements in Web 3.0 are paving the way for financial institutions to integrate services within virtual environments. Now, there are several studies conducted which highlighted the potential benefits of metaverse banking, such as enhanced security, decentralized transaction, and improved customer experiences. Now, DUI theory identifies five key factors influencing innovation adoption. These are relative advantage, which is basically the degree to which metaverse banking is superior to traditional banking, compatibility, how well metaverse banking aligns with existing user habits, complexity, the perceived difficulty of using metaverse banking services, trialability, the ability to test services before full adoption, and observability, the visibility of benefits to others in society. Now, moving on to the research methodology used, this study aims to analyze customer attitudes and adoption intent regarding metaverse banking using DOI theory. The research follows a descriptive approach, employing a purposive sampling technique. Data was collected through a survey of over 300 bank account holders, assessing their intent to use metaverse banking. The study employs structural equation modeling, SEM, using SMARTPLS 4.0 to analyze relationships between adoption factors and user attitudes. Now, discussing about the hypothesis development, we have six hypotheses. H1 is positive attitudes towards Web 3.0 and metaverse bankings are linked to stronger adoption intent. H2 is compatibility of Web 3.0 based banking services positively impacts user attitude. H3 is complexity of Web 3.0 banking negatively impacts user attitude. H4, observability of benefits positively influences user attitude. H5, perceived relative advantage compared to traditional banking enhances adoption. And H6, triability positively influences user attitude. Now, moving on to the results and discussions, the data analysis provided the following. So, demographic features, majority of the respondents were aged between 20 to 30. 30.9% respondents were from finance and banking background. Now, moving on to construct validity and reliability, we have Cronbach's alpha. So, if it is more than 0.7, so I can confirm the reliability of the constructs. So, in this case, in all the elements, it is more than 0.7. Now, explaining the discriminant validity, it shows correlation of one element with another. And we can see here that all of these variables are positively related to each other. Now, construct validity reliability Cronbach's alpha is giving more than 0.7, and average variance extracted is showing more than 0.5. Hence, this is allowing me to take hypothesis testing. So it is basically on the path coefficient route. P value should be less than 0.05. Then our hypothesis is supported. So here we can see that H1, H2, H4, and H6 are supported, indicating positive influences of attitude, compatibility, observability, and triability on adoption intent. H3 and H5 were rejected, showing that complexity discourages adoption and perceived relative advantage doesn't significantly influences user attitude. Now, this can be the case that users know the benefits of metaverse banking, but they are not ready to adopt it. Now, these results indicate that positive attitude, compatibility, observability, and triability significantly impact Web 3.0 banking adoption, but perceived complexity and relative advantage do not have a strong influence. Our study reveals key insights like early adopters drive innovation. Fintech and tech savvy customers are more willing to adopt metaverse banking services. Customers prefer a try before you buy approach before committing to metaverse banking. Complexity remains a challenge. So users find blockchain-based banking solution difficult to understand. And obviously, there are security and trust concerns. Users express more concerns about fraud, privacy, and regulatory frameworks. Now, what are the key implications for banks and financial institutions? So, what they can do is they can enhance user education through immersive tutorials and hands on trials, improve interface design to simplify metaverse banking processes, collaborate with regulatory bodies to establish trust and compliance. While our study provides valuable insight, it has certain limitations like geographical scope. The research focused on India. Results may differ in other countries. So, another limitation is limited sample size. A large, more diverse sample could offer better generalization, and a longitudinal study can provide deeper insights into adoption trends. And future research opportunities are available whereby we can compare the analysis between developed and developing nations. We can explore the role of AI in enhancing metaverse banking security. And we can also expand UI theory integration into different
This is a
industries.
7 minute reminder.
Okay. To summarize, metaverse banking powered by Web 3.0 is an emerging innovation, but adoption is still at an early stage in India. Diffusion of innovation theory helps uh, in understanding adoption drivers such as compatibility, trialability, and observability. And also, financial institutions need to simplify complexity, build trust, and create awareness to facilitate mass adoption. So, our research provides insights for both banking professionals and researchers looking to explore the section of between finance and metaverse. I would like to extend my gratitude to my co-authors, and these are all the references which I took. And also, I owe big gratitude to SMARTCOM conference organizers for this opportunity. Thank you.
Okay, good work and it's one thing you have presented, Shivani. Good presentation.
So, audible.
Am I audible?
Yes.
Okay. So it's a good presentation, Shivani, and a good statistical analysis you have done. So in the presentation, the way you have presented, that is also good.
Thank you, sir. Thank you.
Thank you, Shivani. You can stop presenting now. Next up, I would like to request Shubham Kishore Karam to kindly present his paper titled Artificial Intelligence in Education, an Overview. Do we have you here with us, Shubham? Are any of the team members present? Since no one from the team is there, we'll be moving forward. Next, I would like to request Harish to kindly present his paper titled Biodegradable Packaging for Green Logistics, a multi-factor analysis optimizing sustainability in freight transportation. Do we have you here with us, Harish?
Yeah. Ma'am, am I audible?
Yes, your voice is low. You can just increase the volume.
Yeah. So,
Hello?
yeah, ma'am.
Yes, you are audible. I'll stop sharing the screen so that you can present yours.
So good evening to one and all present here. So let me share my screen. So let me start with my presentation. So it is a biodegradable packaging using green logistics, a multi-factor analysis optimizing sustainability in freight transportation. So myself Harish and my co-author is Drishya Murli and my mentor is Dr. Suresh. So I'm from Amata School of Business, Coimbatore. Uh, So basically, to start with the introduction, the basic function of the logistics is packaging. So the supply chain considers packaging as a crucial element to the logistics. So what is sustainable biodegradable packaging? So the packages that are being promoted by Amazon or Flipkart are nowadays focusing on the sustainability. So due to this, like we can reduce over gas emissions up to 25%. To save our environment, and 72% of the customers are very much evolved for such packaging. So next is the cardboard boxes and bubble wraps are majorly used in packaging, so which have been more crucial. So like the study proposed, like we have used GINA methodology in which beneficial items have been casual, and the influential relationships among factors which requires attention as well. So the study aims to assess the significant factors impacting the logistics while adopting biodegradable packaging. And the study initiates with a comprehensive review of literature and expert insights. Through the analysis, the study analyzed the identified factors which have been most influential to drive the process of optimizing sustainability in freight transportation. So there have been like 11 factors which have been bought from our expert opinions. So the 11 factors are material properties, degradation rate, environment impact, waste reduction, transportation method, logistics infrastructure efficiency, cost effectiveness, product production performance, consumer preferences, ease of packaging, and availability of materials. So next is like we have obtained influence relation by conducting surveys from the experts. So like the expert respondents can rate the direct impact of one factor using the other using the linguistic labels. So like we have bought with the Likert scale like to measure the factors which has impact. So when it comes to the short and clean responses. So we have collected the data from 37 experts and cleaned up to 30 respondents data with 100 questionnaires, which each are finalized. Um, so next is like converting it to the gray scales is the fourth step. So this helps to mitigate the process in stemming from focus green logistics, and answers are based on the table. Like the scales start from very low, low, medium, high, and very high. So next is the responses converted to grayscale or consolidated and aggregated values are achieved. So we have brought in the scores of the 11 factors, and these factors have been illustrated based upon the critical, ideal, and typical value, which influences the model. So we have identified the scores. Like the critical value implies the score of 30, and the factors F1 and F1 cannot be directly influenced. So we brought in critical of value 30, and the ideal value is 90. So by this we are bought in a typical value of average is 60. Like when we get into 90 plus 30, we get 120, and we bought in average of 60. So like through this table, like we can understand that the critical, ideal, and typical values have been illustrated. So we have brought in the direct influence coefficient and the complete influence matrix. So these are the steps and the formulas which have been used in this model. So next is the responsibility and influence. Like influence coefficients are calculated based on the equations of Gray responsibility coefficients and the Gray influence coefficients. So from this, like we have brought in for GIC and GRC for everything critical, ideal, and typical. So among this, like we have found that the factors F1 and F8 has the highest combined influence, that is 0.188. So this has the greatest influence among all when compared. So when it comes to the results and discussion, it says that it provides a comprehensive analysis of adapting to the biodegradable packaging in the freight transportation, contributing significantly to the field of green logistics. So by utilizing the GINA methodology, the research system says that it evaluates the 11 critical steps by focusing on optimizing sustainability, and the finding says that the material properties emerges as the most crucial factors, and the performance in protecting goods impact the packaging in the logistics sector. Like everyone needs, the properties should be covered with many other factors. So to this, like the package is not only about to ensures the safety of the package, but in then the biodegradable packaging should also be protected during the goods. So the packaging needs to be safe and compatible with the wide range of products, including food and pharmaceuticals. So in order to do this, the sustainable production use and disposable processes should minimize carbon footprint. So cost-effective and scalable solutions are essential for widespread adoption in logistics. So when it comes to the performance in protecting goods, packaging must ensure the safety of goods during the storage and transportation, like the goods could be mishandled through transit. So high performance packaging reduces waste by minimizing product losses due to mishandling or spoilage. So biodegradable materials must maintain protective standards comparable to conventional packaging. Like the biodegradable package should differ from the conventional packaging, which have been degrading nowadays. So adequate protection is critical for meeting client and company expectations in.
This is a 7-minute reminder.
So ensuring product integrity through durable and reliable packaging supports sustainable goals. So the conclusion and implication says that biodegradable packaging plays a critical role in achieving green logistics, and the study highlights the need for innovation in materials, regulatory support, and life cycle assessment. Cost effectiveness remains a pivotal factor as business weigh the financial implications of transitioning to sustainable alternatives. So we have brought in some implications for industry policymakers, for consumers, and for future research. And these have been the references which we have been referred, and that's it. And I would like to thank my co-author Drishya Murli and my mentor Dr. Suresh and the other research scholars as well, and SMARTCOM especially to conduct this conference. Thank you.
Thank you, Harish. Are there any questions? Yes, I are audible.
Nice work. And one more thing is continue this research and give some sort of thorough solution to the industry by which they can implement this thing.
Okay, sir. So like through implications, we have bought in like for industry, they must invest in R&D to improve biodegradable materials, and they have to align with the logistics and sustainability goals. So it basically depends upon the organization to organization. So when it
Yeah,
comes,
that's fine. Yes, definitely. If someone want to adopt, then they can. Otherwise, you cannot do anything with that.
yeah, and then the research is going on. So like it is not an easy step to shift from the conventional packaging to sustainable packaging. So for future research, like we have to explore the alternative methodologies, life cycle analysis, and cross industry applications for broader insights.
Yeah, okay. Thank you.
Thank you, sir.
Thank you, sir. Thank you, Harish.
Thank you, ma'am.
Moving forward, I request Utkarsha Vanjari to kindly present her paper titled Bridging the Digital Divide, the Role of ICT in Promoting Inclusive Social and Economic Development. Do we have you here with us, Utkarsha? Are any of the team members present? All right, since we don't have the team with us, we'll be moving forward. I would like to request Ma'am Vasudha to kindly present her paper titled Context-Aware Data Synchronization in Ubiquitous Networks. Do we have you here with us, ma'am?
Yes, madam.
Yes, sir. Yes, ma'am.
Shall I start?
Yes. Please, you can
Okay,
share your
thank you,
screen.
thank you.
Yes. Yes, your screen is visible.
Yes, madam. Good afternoon,
Can you please,
sir.
can you please put it in a presentation mode?
Yes, madam. Yes, nice, thank you. Is it okay, madam? No?
No, it's not. Yes.
So, myself.
Your screen is visible, but it's not in the presentation mode. But okay, you can
Yeah,
start.
I'm getting, madam. Just a minute.
Yes.
So, myself, Vasudha, from Official
Yes,
Information.
ma'am.
Ma'am,
The
is it
screen
visible?
is. Sorry.
See, is it visible, madam? Slideshow?
The slideshow is not visible. The slides are visible, like the. And anyways, you can continue
Okay,
like that.
okay.
Thank you.
So, I'm going to present on context for the data synchronization in indicator structure. So, myself, Vasudha, I'm presenting the paper as a representative for the co-authors, that is Dr. Lokesh Bajantri sir, Department of Computer Science and Engineering, Professional
I'm
Science.
sorry, ma'am. Your voice is not clearly audible. It's breaking.
The contents of the presentation, ma'am, is it okay now?
Yes, it's better now.
Okay, ma'am. The
Yes,
contents of
thank
the
you.
presentation goes like introduction, proposed work, simulation, work results and discussions, conclusion, and the references which are referred. So ubiquitous network. Ubiquitous network, I can say that it is a network of computing devices which is having various set of heterogeneous networks and which are connected with multiple devices where users can access the services and from any place, anytime, whatever the services the user wants, he can access from any of the places. And these ubiquitous networks allow the users to access and exchange the information from various heterogeneous networks. So like wireless sensor, WSL, various WANX, or they can be Bluetooth or cellular networks, various heterogeneous networks through which the users can access and exchange information from various users. So these ubiquitous networks are the proper integration of the core network, access networks, ubiquitous applications, and the sensors. And mainly these ubiquitous networks are originated from the ubiquitous computing where the users can access the information from any of the places. The main aim of these ubiquitous networks is to make any computers available throughout the physical environment and make the users familiar. Means wherever the user can go or move, he can access the services which he wants and whatever the task he wants, he can perform it any place and any place from where he can access the information. And the architecture of this ubiquitous network consists of four different layers, as in the figure, which consists of physical layers, in which various heterogeneous networks are there, cellular networks, wireless sensor networks, and WAN-H, and various other heterogeneous networks are included in the physical layer, through which the users can access the or perform the task. Network layer, so the network layer consists of the components which act as a network administrator to provide the services to the users through the ubiquitous computing layer. And the ubiquitous computing layer consists of various applications or the functionalities through which the user is going to access the applications which are listed in the application layer, like ubiquitous services, context awareness, fault tolerance, data synchronization, and the data processing are some of the services, and which are also the challenges where we need to deal with all these challenges when dealing with ubiquitous computing, ubiquitous network. And the application layer where through these ubiquitous computing environment, users can access various types of applications in terms of they can be in terms of hospital management system, they can be any of the agriculture related applications, or they can be disaster management system. So this is the architecture which represents the ubiquitous network environment. And so one of the important challenges or issues in these ubiquitous networks, as it consists of various heterogeneous networks, the data from various devices will be there, and the computing and computational capabilities of various devices will be different. So it becomes essential to have the data consistency among all the devices, where the information or the data will be accessed by various users through the heterogeneous network. So data synchronization is one of the important challenges or issues in these ubiquitous networks. So data synchronization can say that it is a process of exchanging information. Means whenever the data or information is exchanged among various devices, there should be a data consistency among those various devices through which the information can be provided to the various users. And these ubiquitous users can, any kind of transactions can be done by the various ubiquitous users where the data can be provided at any time, anywhere. And these systems allows the users to access the data, and they must address the challenges that are with respect to the data synchronization. And this data synchronization is used to resolve the conflicts which may exist. Means conflicts means there can be possibility of having ambiguities in the data that has been stored in various devices, and those conflicts must be resolved when we are going to deal with the data synchronization or whenever the data or the information is accessed from these networks. And when we are going to deal with these or resolve these conflicts, so it must ensure that the data consistency among all the devices must be maintained. So the data synchronization is used to save the data in mobile devices, so that can be locally or that can be globally. So the data that we are going to maintain must be consistent among various devices which we need to have. And whenever the mobile devices means when we are going to say the data synchronization, so the devices can be mobile devices or they can be the static devices. So whenever the mobile devices are connected to the network, the data is synchronized from one device to another devices ubiquitously, so that the consistency among all those information or the consistency among all the devices with respect to that data is maintained. So it is necessary to establish the effective data sharing. Whenever the data is to be accessed from various devices, the data sharing and the synchronization between all those devices is required. And the server under which the devices are considered as a constraint for maintaining the data consistency are the network changeability. Means so whenever we are going to shift from one place to another place, the network existence will be changing. So the network changeability, data inconsistency, data conflict, wireless network bandwidth.
Hello. Thank you, ma'am. Am I audible? Hello.
Yes, you are.
Okay. Are there any questions? Since there are no more questions, I'll be moving forward. Next, I would like to request Ganesh to kindly present his paper titled Droid Guard Integrated Malware Scanner. Do we have you here with us, Ganesh?
Yeah, I'm here.
Right,
I'll
I'll
share my
stop
screen
sharing
now.
so that you can. Yeah.
Sure. Could you please tell me if you can look at my screen?
Yes, it's visible now.
Okay, all right. Give me
Can you
give me 1
please?
second. I'll quickly change the slideshow.
Yes.
Yeah. So good evening, everyone. So the title of my project is DroidGuard Integrated Malware Scanner, where I tried to develop a malware scanning tool, and I assume that I have succeeded. And these are the table of contents of my paper, like in my project. So I'll give you a brief introduction of what my project is, then I'll tell you what motivated the idea, then I'll take you through the existing methodology that's present now, and I'll tell you about the proposed methodology, project architecture, and then what's unique in this project, and then implementation of it and results of it, and then the final conclusion and the points that I found during this project. So moving on to the introduction part. So we all know that we have been using smartphones a lot nowadays. Like we communicate through smartphone, work through smartphone, we access any kind of information through Google using DNS, and anything is accessible with smartphone nowadays. So even though the work of us has become easier using smartphones, the comfort comes with its own set of security challenges. Like there is a chance that our devices can be compromised by malwares. Even though there are multiple antivirus applications and CM tools that can detect malwares, still removing malware remains a significant challenge, and detecting it remains a significant challenge. So often these solutions fail to detect sophisticated malware. Like if there are any zero-day attacks, the solutions are failing to detect the malware. So my idea of project is to develop a tool which will detect the malware based on the combination of signature-based and heuristic-based detection, which I'll be covering further. And this tool will be efficient and privacy-preserving. Moving on to the motivation of project, like existing antivirus solutions as and we have CM tools like Splunk. These two try to detect malware and remediate whenever required, but we see that there are a lot of false positives being generated there. I'm a part of incident response team myself, and I see a lot of false positives being generated every day. So in order to tune that, it has become very tough for everybody that's working. So in that case, I thought a combination of signature-based detection and heuristic-based detection using Boyer-Moore's algorithm could be used in order to enhance the malware detection part, where I'm not using traditional detection methods, and I'm using malware packages to detect the kind of malware it is. So as I already told you that existing methodologies use either signature-based detection, which is totally dependent on malware signatures that are present on like maybe threat vault, etc. and tool. So heuristic analysis is based on like detecting the malware based on its behavior, patterns, characteristics, and all. So in this particular project, I'm using both in a way like in a way the proposed methodology that I'll be telling you now what the idea is. So whenever we have an Android mobile, I'm connecting it with an ADB bridge, so I'll retrieve all the all the packages, not malware packages, all the packages present on that device, and I'll be storing it in a file. Then I'll compare it with the database like CIC. There's a benchmark data set which I'll be covering further. I'm comparing it with that which contains like benign packages and true positive packages, so benign and malicious packages. So when we compare with them, then we can easily get to know that the previous is compromised or not. For that, we have used Boyer-Moore's algorithm. And this project works basically on project in pattern matching, and it compares the installed packages and versions with database entries. If a match is found, the tool indicates that the malware has been detected. So the main purpose of the project is to address user concerns, like the tools that we use, like currently antivirus applications like Defender and all. They all ask for extensive permissions from the users in order to work on behalf of them. So you have a chance of compromising your privacy there. So one should not be getting security in exchange of privacy. So I strongly believe in that. So this is a privacy focused alternative, and it also enhances security better than the CM tools that are existing. And this is the architecture, the way that my project works. Like, this is a smartphone, and then we extract packages using ADB Android debugging bridge. Using that, we get the packages. Then this is the tool that I'm using, malware analyzer. That tool will be comparing the extracted packages from mobile and the malicious packages we have from the database, and then based on the comparison we get the output. So in order to be more clear on that, we use the package manager command to get the packages, and then we can match the packages with the dataset. If a match is found, the output would be malware packages found. If a match is not found, no matching malware packages are found. That would be the output. So the unique selling points in this tool are like, it is privacy preserving, it is user friendly, like unlike traditional antivirus softwares, it cannot miss a malware because we collect dataset, we collect the data from dataset and we directly collect the packages from mobile. So there is no chance of a malware being missed here. It also eliminates the need for users to trust third-party apps. So the primary tools required for this project to be working are, you must have an Android device, and Python DB for database creation, ADB server for connecting with database, connecting with smartphone, and a terminal at the minimal level in order for this to work, and then the USB cable to connect your smartphone with the device that you use. So these are the possible outcomes from this project. Like the first possibility could be malware packages found, or the second possibility could be no matching malware packages found. So the most important part in this project is like data collection, that it requires critical attention and the most care here. So I have thoroughly reviewed all the data sets that are available, and I decided on using CIC and MAL 2017 dataset, which has like 1900 samples, and I'll tell you clearly in further slides about how I use them. So I converted the data from them, and I collected packages and then created a JSON file for database. Then I've compared the packages with the packages present in smartphone. So this is a sample of the data that I've collected. Like, these are all the flagged packages.
This is a 7 minutes reminder.
Yeah. So moving on to implementation. So this is the Genymotion server. Like, for the demo purpose, I have used a smartphone instance. And here, this is the most important part of my package, like where I compare the existing packages with dataset packages. And if you can see here, we have the output. Like, for example, when I tried that instance, I had a malware package found, which was com.android Android providers contacts. It is a contacts, and it is not malware actually, but I have added here in the database in order to show that this works. And I have also added detection results on unknown samples. Yeah, so in the data set we had 1900 samples, and in those 1900 samples I've seen that 1000 were malicious and 900 were benign. And my project has secured 95.2% accuracy. I've compared it with Debian SVM model and Bayesian model, which have like around 92 and 94. while my model has acquired 95 plus accuracy. So I would suggest that this is the best approach so far. And
I request you to kindly conclude your presentation, Ganesh, as we have crossed the time limit.
Yeah, sure. So to conclude that, this is since I have used novel pattern matching algorithm technique to find a malware scanning tool. This has been a great idea, and I'd like to thank my team members Karthik and Pranay Govin, and also my mentor Vinod Kumar sir. And I'd like to thank SmartCom 2025 for providing me such a wonderful opportunity to present my idea.
Ganesh, real-time application you have addressed, and nice work you have carried out.
Yeah, thank you, sir.
Thank you, Ganesh. Thank you, sir. Moving forward, I now request Sir Sanat Kumar to kindly present his paper titled Improving Accuracy in Coronary Artery Disease, Diagnosis with an Artificial Neural Network, Bagging Ensemble Learning Classifier. Do we have you here with us, sir?
Yes, ma'am.
Yes, sir. Can you please present your paper? I'll stop sharing my screen now.
Okay. Is my screen visible, ma'am?
Yes, sir. Your screen is visible. Can you please put it in slideshow mode? Yes, it's visible. You may start now.
Okay. Good afternoon, sir. Session chair, and good afternoon, ma'am. Myself, Dr. Sanat Kumar Sahu, Department of Computer Science, Government VIT PG Autonomous College, Durg. I am presenting my research topic, improving accuracy in coronary artery disease diagnosis with an artificial neural network, begging ensemble learning classifier. My paper ID is 498. This is so the table of content. In table of content, I included introduction, literature review, proposed methodology, resultant discussion, conclusion, and the references. Introduction: coronary artery disease is a leading cause of mortality in mobility worldwide. Early and accurate diagnosis of CAD is crucial for effective treatment and improved patient outcome. While traditional diagnostic methods have a limitation, machine learning techniques have emerged as a promising tools for enhancing coronary artery disease diagnosis. This research explored the application of an artificial neural network begging ensemble learning classifiers to improve the accuracy of coronary artery disease diagnosis. By combining the strength of artificial neural network and ensemble learning, this approach aims to develop a robust and reliable diagnostic model that can assist clinicals in making more informed decisions. This slide shows the literature review. Already done previous researchers in the field of coronary artery disease. The name of author, dataset, algorithm, uh, outcomes. All the data set worked in the authors is basically related to coronary artery disease or heart disease. Outcomes is represented. Techniques used like decision tree, uh, Naysian bias, stack-based ensemble model, neural network, and genetic algorithm with neural network. Next, proposed methodology. This study proposed a data mining and machine learning methodology for coronary artery disease diagnosis employing multi-layer perceptron network and radial basis function network classifier. Critically, it introduced Bayesian ensemble version of this model to improve the performance of our proposed model. This is so the our proposed diagram. Left side So the data set, we are collected data set from UCI machine learning repository. The data set name is Z Elijade Saini. This data set having 303 instance and 58 features including class level. And next second data set is extension of Z Elijade Shani. This data set having 303 instance and total 59 features. Then we applied this data set in a classifier, radial basis functional network, and in a sampled bagging radial basis functional network, multi-layer perceptron neural network, and in a sampled multi-layer perceptron neural. These all four models compared the performance compared with each others, and performance parameters used accuracy, sensitivity, specificity, F1 score. Then finally we find the best model. These are the data set name. Jet Ali Jade, available in UCI machine learning, MLP, RBFN, bagging in sample techniques already discussed in the proposed methodology diagram. Result and discussion. The classifier learned training and validation using a 10-fold class validation methodology. The demonstration of the anti-self model in terms of accuracy, sensitivity, specificity, and F1 scores. These are reflected in a table 1 and a table 2. Table 1 show the performance of classifier with CAT dataset Z Ali Jade Sun. This dataset with classifier names RBFN, EBFN, MLP, EBPML, the highest accuracy find out compared to all others model 84.82 in assembled bagging multi-layer perceptron models, and the highest F1 scores. Table 2 shows the performance of classifier with dataset EJZ. In this dataset, the highest performance model is in bagging, in assembled bagging MLP models, 98.35%. This is the graph, compare both dataset. In the graph is clearly so that the in assembled bagging model MLP shows the highest performance in both dataset. So we can say that the in assembled bagging multi-layer perceptron model is best suitable compared to all other models. Conclusion: the investigational consistency showed that the projected in assembled model, mostly in assembled bagging model, provide higher accuracy for both dataset related to specific MLP and RBFN classifier. Basically, the projected in assembled model EBMLP model provided 84.82% and 98.35% accuracy for the CAD, Z, and CAD EZ dataset respectively. This still demonstrates the effectiveness of bagging in assembled method for improving the CAD diagnostic accuracy compared to the individual MLP and RBFN classifier. The bagging approach enhances the performance by reducing variance and creating most robust model. The final, this improved accuracy has the potential to add clinical in more reliable diagnosis, leading to better patient outcomes. These are the references we used. Thank you.
Thank you, sir. Are there any questions? Since there are no questions.
Okay, ma'am. Thank you.
Yes. Moving forward, I request Pampati Sriya to kindly present her paper titled Indian Stock Market Prediction Using Neural Networks, a comparative analysis. Do we have you here with us?
Yes, ma'am.
Yes, we are here.
Okay, I'll stop sharing the screen so you can present yours.
Okay. Is it visible?
Not yet.
Now?
Yes.
Okay.
Just. Yes, it's visible. You may start.
Okay, hold on. It's visible, right?
Yes, it's visible.
Okay. So, good afternoon, everyone. I'm Yashasvi, and me and my co-author Shreya will be presenting our research paper titled Indian Stock Market Prediction Using Neural Networks, a Comparative Analysis. So, this is the agenda that we are going to follow today. That is introduction, literature review, issues and challenges, problem statement, methodology, results, discussion, and conclusion, and the future scope in the end. Moving on to the introduction. So, stock market prediction is one of the most challenging problems in financial markets due to its highly nonlinear, volatile, and dynamic nature. Investors, traders, and financial analysts constantly seek for accurate forecasting techniques to make informed decisions. However, traditional statistic methods like ARIMA and GARSH struggle to capture the complex dependencies in the stock prices. In recent years, deep learning models have demonstrated superior performance in pattern recognition tasks, including stock price prediction. So, the CNNs and LSTMs are two popular architectures that have been explored in financial forecasting. CNNs are excellent in extracting the spatial and local patterns from the time series data, whereas LSTMs are designed to capture long term dependencies in the sequential data. In our study, we compare a standalone CNN model with a hybrid CNN LSTM model to predict the stock prices in the Indian stock market, specifically using the Tata Motors historical stock data. Moving on to the literature review. Numerous studies have explored AI and ML techniques for the stock price prediction. According to Mukherjee et al., LSTM models are particularly effective in capturing sequential dependencies compared to traditional models like ARIMA and GARSH. Fatali et al. They demonstrated that CNNs are highly efficient in extracting short-term patterns from stock market movements. A more recent study by Sen et al. Proposed a hybrid CNN LSTM model which combines the feature extraction ability of CNN with the sequential learning capability of LSTM. Their findings suggest that hybrid models can improve prediction accuracy by leveraging the strengths of both architectures. So, despite these advancements, several challenges still remain. The market volatility, data quality issues, and overfitting are significant obstacles in the stock price prediction. Our study aims to address these challenges. So, the issues and challenges, I have already discussed these. And the problem statement. Moving on to the problem statement. Our research is driven by a fundamental question: can a hybrid CNN LSTM model outperform a standalone CNN in predicting the stock prices? To answer these questions, we focus on the three key objectives that are short-term trend detection, long-term dependencies, and volatility handling through an ensemble approach. Yeah, and Shreya will talk about the methodology and continue.
So coming to the methodology part, we have used the historical stock data of Tata Motors from 2000 to 2024. These features include open, high, low, close, and volume prices. So coming to the CNN model, it extracts short-term patterns using convolutional filters and max pooling. And then the hybrid CNN LSTM model uses CNN for feature extraction and LSTM for long-term trend detection. So both models use the Adam optimizer and MSC loss function to minimize prediction errors. Training loss, validation loss, and test loss are used to assess model performance. Next slide, please. Coming to the results, these are the results that we have obtained. CNN has a lower test loss, meaning it generalizes better. And coming to the CNN, the LSTM has lower training and validation loss, but its higher test loss suggests overfitting. While CNN plus LSTM captures long-term trends, it struggles with new data, highlighting the need for future optimization. We can go to the next slide where you can see the graphs that we have plotted. This is for the CNN model, and the next one is for CNN plus LSTM model. Next slide. Coming to the discussion, CNN effectively predicts short-term trends but struggles with long-term dependencies. But hybrid CNN LSTM improves long-term forecasting but may overfit the training data. The hybrid model learns complex patterns better but requires optimization to generalize well. A balanced approach using both models can help in capturing stock market dynamics more effectively. And then coming to the conclusion and future scope, CNN is effective for short-term trends while CNN LSTM captures long-term dependencies but requires optimization. And hybrid models have potential in financial forecasting, but issues like overfitting must be addressed. Coming to the future research directions, including sentiment analysis and macroeconomic indicators could improve predictions during market fluctuations. Using techniques like dynamic weighting in ensemble learning can enhance the performance, and applying this approach to different stock markets will help validate if its effectiveness. So the closing statement would be this study highlights the potential of AI in stock market prediction, while challenges remain continuous improvements in data. Deep learning models can lead to more reliable financial forecasting systems. Yeah, that's it. Thank you.
Thank you, ma'am.
Okay,
Thank you,
so
Shasvi and Shreya.
yeah, so the result that you have compared with CNN LSTM model, you should compare the result with only LSTM model.
Yes,
Right?
sir. Yeah.
So you can do, and the thing is the evaluation measure that you have used, that you are using loss for training validation and all. So better evaluation measure you should incorporate, like it might be you have predictions past stock price. So you can have MA, RMSE for evaluation for this proposed approach.
Yes, yes.
Yeah,
Okay,
you
sir.
can
Will
try
you-
more sequential model in your research, and you can continue this research further.
Okay, sir. We'll try to improve it.
Yeah.
Thank you, sir.
Thank you, sir. With this, I would like to request Mohammad Umar to kindly present his paper titled Network Intrusion Detection System Using Learning Algorithms. Do we have you here with us, Umar?
Yes, ma'am. Is my
Yes, right.
voice audible?
Yes, your voice is audible. I'll stop sharing so that you can present.
Sure. Hello. Is the screen is visible?
Not yet.
Not yet.
Yes, it's visible now. It's not properly visible.
1 second, give me.
Yes. Uh,
Hello. Is the screen visible now?
yes. It's the
Okay,
screen is
fine.
visible, but there's something on your screen, like the slide.
1 second. I will remove. Is the screen visible now? Hello.
It's visible. It's visible, Omar, but there's something like a black box coming on your slides. I don't know if that's a technical glitch from your side. Maybe you can try presenting again.
Okay, fine. Good afternoon, everyone. My name is MD Umar. I am honored to be here today to present my paper. I am currently pursuing BTech third year in CSC AML at Institute of Aeronautical Engineering, Hyderabad. And my co-author name is Dr. J. Shivaram Krishna sir. He's a professor in the Department of CSE AML in Institute of Aeronautical Engineering. And coming to my paper title, Network Intuition Detection Systems Using Learning Algorithms, and the paper ID is 523. And the presentation outlet goes as abstract, introduction, literature review, research gap, proposed methodology, class imbalance, rare attacks and detection, machine learning models, performance evolution, emerging threats, future work, conclusion, and reference. In the digital era, the network security plays a major role. Here comes the traditional network intuition detects rely on only signature-based and anomaly-based. In this presentation, I will walk you through the challenges faced by the traditional NIDS and explain the proposed methodology we use it to develop our system and the class imbalance and the key results that demonstrates its effectiveness. Let me give you the brief introduction about this network security. In today's
Umar,
digital
I'm sorry.
age,
Umar,
hello?
wait. There's something on your screen. Your slides are not clearly visible. Can you just check the message once?
Okay. Is it clear?
Just see if that's it. It's
Now is it clear?
you
Hello?
it's still there, but okay, you can present.
Still
Yes,
there?
please keep going. Please
Okay,
keep
fine.
going. It's okay.
In today's digital age, network security is a paramount for protecting the sensitive information, and the cyber threats are evolving rapidly, making it crucial for organizations to implement robustness security to defend against potential attacks. What is this IDS? And network intuition detection identifies the potential threats and weaknesses in network systems. An IDS examines network traffic, alerting administration to suspicious activities without intervening in data transmission. Now comes the network intuition detection systems designed to monitor network traffic and detect suspicious activities that could indicate a cyber attack and or unauthorized access. There are different types of traditional approaches like signature-based and anomaly-based. As cyber threats becomes more sophisticated and evolving, these traditional entities struggles to maintain high accuracy and low false alarms rate. Now comes the role of learning algorithms in these NIDS. The traditional approaches like signature-based and anomaly-based struggles with new and unknown threats, whereas these machine learning algorithms and deep learning offers more adaptive and intelligent methods for network intuition detection. These technologies can learn from historical data, identify complex patterns, and improves the detection accuracy and reduces the false positives and false negatives too. These are the literature reviews I have used in the paper titles. The key points in these literature reviews are they have mainly used the signature-based detections and anomaly-based detection. In many of the papers, they have discussed only explored about the one or two methods like support vector machines or decision trees, or else CNNs or RNNs. Using labeled data to train the models, they classify the network as normal or malicious. Common algorithms like decision trees, random forest, and SVMs are used in these papers. These algorithms shows promising in improving detection rates for known and unknown threats, can achieve high accuracy with sufficient training. But the main weaknesses are the deep learning algorithms lack real-time applicability, struggle with high dimensional data, or fail to optimize feature selections and leading to inefficiency in practical deployment. The main research gaps are like over-reliance on accuracy as the primary metrics, the lack of effective features selection in existing models, and limited attention to the handling class imbalance, limited comparison of multiple algorithms, and underdeveloped evolution of the real-time scalability. Now, let me go through the methodology I have proposed. The first step is the data collection, and after that, we'll go to the data processing and exploring of data and understanding the data sets, handling the missing values, and removing the duplicates, scaling using min-max scaling. And after that, we will use feature selection. In this feature selection, we'll use multiple information and PCA. And after that, we'll use handling class imbalance. It's an important part, addressing imbalance using smart sampling technique to improve the detection of the rare attacks. And after that, we will train and test in the model selection, like testing multiple classifiers and the performance evolution. This is the flowchart of this methodology. And the EDA count plots shows the normal and anomaly graphs. These are the TCP, UDP anomalies and normal classes. These are the 41 feature selections in the KDD 99 dataset. Now comes the major part, the class imbalance. Many papers have not discussed about this class imbalance. Class imbalance is a major challenge in NIDS, particularly for detecting rare attacks types like UR2R, which is user to root. And to address this, we have used SMART to generate synthetic samples, the minority class. Applying SMART to balance the dataset, improving the detection rates for rare attacks like U2R and remote to local. The impact of this improves to recall the rare attacks and reduces the number of false negatives. And our model ensures better detection of the attacks that are often missed by the model that not addresses by class imbalance. The machine learning models I have used in this paper are random forest, chosen for its ability and handling higher dimensionality data robustness to overfitting, and next bagging classifier to improve its stability by reducing variance across decision trees. And now comes the decision tree used as a baseline model and XGBoost and so on. Models discriminate between regular traffic and abnormal traffic like anomaly, lower computational complexity, effective on basic CPU hardware, effective handling on data, and higher interruptibility, like important for IDS. These are the code outputs and the model performance. The random forest classifier achieved 99.81 accuracy with a detailed performance matrices as precision recall F1 score for all the models I have used here. Random forest classifier, bagging classifier, XG classifier, and decision tree, and so on. These are the code outputs of the classification of the random forest and the confusion matrix for the random forest. The emerging threats and the future works like adapting emerging threats plan to incorporate adaptive learning mechanisms to handle evolving threats
This
such
is a
as AI-powered
7-minute reminder.
sure. AI-powered attacks and advanced persistent threats like ATPs. And the main aim is to improve the model scalability for deployment in high traffic and real-time environments. The future optimization will focus on minimizing false positive in real-world network environments. And the conclusion of this paper is proposed a machine learning based NADS using random forest and bagging classifier. The model, the random forest classifier was the most effective, but the other models were also evaluated. The model successfully developed a highly accurate NIDS using machine learning. The proposed NIDS is strong potential for real-time deployment in high traffic networks. The model adaptability and low computational requirements makes it high scalable for large network infrastructures, increasing its real-world application potential. And the future work could focus on real-time deployment and handling adversarial attacks. These are the key references I have used in the paper. And thank you. Thank you for SmartCom for giving this opportunity to present my paper.
Thank
So,
you,
any
Umar.
method, like feature selection method that you have used in your research?
Sir, can I? Hello?
There are many features in your data set. So
Yes,
to
sir.
select specific features, have you used any feature selection method?
Yes, sir. I have used PC and mutual information methods, sir, to
Okay.
reduce the dimensionality.
Okay. Thank you.
Thank you, sir.
Thank you, sir. With that, we concluded the last presentation of our session. Thank you to all the presenters for their insightful contributions. Before we move to our closing remarks, I'd like to invite Professor Rana Kumar to share his thoughts on the presentations of the day. Over to you, sir.
So it's good to present in such conference, and this is the baby step for your research journey. So keep doing such research and helping society by your research. And thank you, SmartCom, for having me and for such nice arrangement.
Thank you so much, sir, for joining us for this session. I sincerely thank all our authors for their excellent presentations and contributions in this session, as well as all the participants for being part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 9th version and all the previous 8 versions of the conference. We'll be happy to have you in the 10th version in 2026 as well. All the presenters would be getting their digital certificates through email within the next 2 days. Further, all the papers have already been forwarded to the printer. The publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2025. I also thank our session chair, Professor Ronak Kumar, for chairing this session. As a small token of appreciation for you, sir. From the team of SMARTCOM 2025 and Global Knowledge Research Foundation and partners. Thank you everyone for your valuable presence. I kindly request you all to switch on your cameras for a quick snapshot of the virtual conference. Is everyone there? Harsh? Yes. Okay. 1, 2, 3. Thank you everyone. Have a good day. Bye.
Thank you, sir, once again.
Thank you, sir. Thank you so much.